what needs to be done. So the first thing I'm going to do, just remember that everything you say in class right now is being recorded. Okay, we're going to look at the box problem. And this is an example of a good write-up. It has correctly defined the problem statement, clear and easy to follow, demonstrating the process used, provides reasons for the steps, explains meaning of the variables, used accurate and appropriate mathematical terminology, includes all calculations, grammar and spelling are correct, work is completed and well organized, work is submitted on time. Okay. This is an example of a perfect write-up. From a 12 by 9 sheet of cardboard, I was to create a box with dimensions that maximize the volume of the box. To go about doing this, I used my prior knowledge of solving for volume to find my equation. I must also create a lid. Problem statement stated. Check. Knowing that length times width times height equals the volume, I was able to set up my equation because the box would be cut on both ends. The cut lengths must be multiplied by 2. So 9 minus 2x times 12 minus 2x times 2 equals volume. Okay, and I don't think they mean 2 here, I think they mean x right here. I created the sides, the corners must be cut off. To find how much to cut off, I started with an inch cut and moved up from there, checking which ones would create the largest volume. So here's the cut length, plug it into the equation, find the volume. The x, so they're defining the variable right here. The x, or cut length, is the same as the height, making my formula length times width times height. Because the greatest volume was 1.5 inch cuts and the second greatest was 2 inch cuts, I went between both of them to get a more exact measure. A lot of you graphed this. You could have done it guess and check like this, but you could have had a beautiful graph. 1.65 gave me this volume, 1.7 gave me this volume, and 1.75 gave me this volume. Because 1.7 inch cuts showed to be the best, I went slightly above and slightly below 1.7. 1.7 showed to be the best option to maximize the volume. So I show my diagram here at 12 by 9 with 1.7 cuts on all sides. So I plug in 1.7 and I get all of my dimensions and my new volume. So the dimensions of the box are 5.6, 8.6, 1.7 with a volume of 81.872 inches cubed. Because the opening of the box is 5 by 6 by 8 by 7, I know the lid must be larger. It must also have a 1 inch rim remaining an extra inch on each side. So the lid didn't sit upon the box. There must be a gap between the lid and the sides of the box, roughly 0.5. That would cause the lid to be partially fall off, okay? A room allows a perfect fit. So 9 by 6 by 7 by 6, okay? The dimensions of the sheet of the lid are 10 by 6 and 8 by 6, okay? In conclusion, the box dimensions are 5 by 6, 8 by 6, and 1 by 7. Dimensions for the sheet of the lid are 10 by 6 by 8 by 6, and then we cut off to make 1 inch on each side, okay? All right, so let's look at your write-up rubric that is due today, but you could always decide to get a few points off for turning it in slightly late so that you end up with a better score. Documentation of the process is clear and easy to understand, could be easily replicated. Grammar and spelling are correct. The graphs are correct and labeled and are easy to read and understand. Okay. Graph was done accurately. Data points and equations are on the same graph, and correct predictions of the solution of the problem. Gave further examples about what you could do differently. All work done accurately. Responsible for completing your task. Able to provide and receive feedback. You didn't work with group members here, but you might have collaborated, and so you can talk about that. Like, you asked other people what they got to help. Work is completed and well organized. Work is submitted on time. So you were able to accurately apply the graphs, tables, and word problems and the method of organizing the data in a graphical representation. We're done. Okay? So right now, if you feel comfortable that your write-up is done, turn it in now. Okay? Otherwise, you might miss some of the points for your work not being submitted on time, but if you could get a higher grade, you can do it on Monday. If you're good, there's a stapler here and you're going to put it in a pile. It doesn't matter. I don't care what order. Make sure your name is on it. I need your write-up, graph if you have one, and your rubric, which has the problem statement on the other side.
Thanks, Mom.
Martha, you still want us to turn in the other two things if we don't, if we're not doing write up?
Nope. Wait till Monday.
That's great.
All right. So today, I need you to get out your notes because we're going to look at how we're going to use matrices to do this.
Ooh.
Okay? So I would like you to title the section of your notes in your notebook using matrices to solve a quadratic or a second degree polynomial or higher.
Are you going to check these notes on Monday? Are you going to check these notes on Monday?
Notes are for your benefit, not for mine. Everything your teacher writes on the board in every single class you have, you should write down. That should be your rule always. Okay. So this is, for example, if I give you points, can you find the equation of the graph? So one important point for this is on the 2nd of December. To do this, you need one more point than degree. Oops, maybe cannot spell today. Okay, so what that means is, for example, how many points, this is a question for you guys, how many points do you need for a quadratic? Or, another way to put it is ax squared plus bx plus c equals y, a second degree polynomial. many points do you need, guys? 3 points. Okay, I'm going to rewrite this equation down here. ax squared plus bx plus c equals y. Okay, so this is going to take a little work where we have to write it out, but you will need your graphing calculator in order to put in the matrices. So please don't share them either. Please make sure each person has one. Okay. And here are my points. -1, 2. 2, 8. 3, 14. Okay. We can't just put these points into anything. You know what? I'm going to have to ask you guys to move back to your assigned seats if we continue this. We need to focus. Okay. So we're going to plug -1, 2 into this above equation. So we're going to get a times -1 squared plus b times -1 plus c equals 2. And then we're going to do the same thing with 2, 8. We're going to get a times 2 squared plus b times 2 plus c equals 8. All right, somebody want to try the third one? 3, 14. What am I going to get? 3 what?
Squared plus b times plus c.
Okay. The reason I want you to write it out like that is it's a little bit difficult to put it into your matrices than when we do linear, because we have to change some things. Okay. So I'm going to make my matrices. Instead of -1, what's -1 times -1? Then I have -1, and then I have 1. Remember, I'm going to take it to the -1 power like we've done before, and I'm going to times it by the answer matrices. 2. Okay? My next one, it's not going to be 2, it's going to be 4. Yes, ma'am. What? Okay. So do you guys see how I took this one and put it here? This one and put it here. This coefficient, put it here. And finally, the answer matrices. So far, so good? Okay. So 2 squared is 4. And we put a 2, we put a 1, and we put an 8. 3 squared is 9, 3, 1, and 14. Any questions so far? Okay. I want to find out what this equals. So now's the part where you have your calculator. And I'm going to go for live presenter up there so you can see what you type. Okay. So a lot of you probably forgot even where to find matrices in the first place, right?
Yep.
Okay. So first thing I'm going to do is I'm going to find my matrices, which is right next to my 9. Remember in Live Presenter you can see what buttons to push? Okay? Right there. It should pop up. So see how it shows in red what button I just pushed? And then this pops up. Okay, this is a 3 by 3 matrices, correct? So I'm going to click this middle one, whichever pops up. And 3 by 3 is right, so I hit enter. And I'm going to enter the numbers. 1. I like to do tab. You can do arrow over. So it switches to the next one, so you don't have to move it. -1, 1. And then I'm going to hit 4, 2, and 1. And then I'm going to hit 9, 3, and 1. Make sure you don't mix them up or put a negative in the wrong spot or put a wrong number because it messes up the whole problem. And then I'm going to push my arrow over. And I'm going to do this little, it looks like an up arrow key below the, shoe below the control button. And I hit -1. I push my arrow over and I hit times. Am I going too fast? I hit matrices again. And I'm going to have 3 rows but only 1 column. And I'm going to put 1, 1, and 2. Oh, that's not what I'm going to put. Those aren't the right answers, guys. 2, 8, and 14. And then what do I do? 1, 1, 2. Okay, double check your matrices. If it's slightly off, it messes it up. Okay, I'm going to switch back to my paper because I want to show you what those numbers mean. Okay, switching back to my paper. Okay, so I get the answer. You okay, Abby?
Yeah.
All right. I get my answer as 1, 1, 2. That means it's 1x squared plus 1x plus 2 equals y. It's giving me my equation. What do we think?
Easy.
All right, we're going to try a harder one. Okay, ready? I'm going to move the paper. Anybody need it for another second? Okay. We're going to calculate the equation of a cubic. How many points do you think I'll need for a cubic? So a cubic is to the what power? And we need 1 more point, so we need 4 points needed. Okay, here are my 4 points. -2, 17. -1, 11. 2, 5. And 3, 27. Okay. What does a cubic equation look like where I have like A's and B's in it? Do you guys know? AX plus plus D equals Y. Doesn't really matter what letters you're using, just so you know that it goes like that. Okay, so I'm going to plug in -2 and 17 in here first. And I'm going to get A times -2 cubed plus B times -2 squared plus C times -2 plus D equals 17.
Do we have any of these on the phone?
Yes. Any questions about this? So I'm trying to go slow enough so that if you are confused about something, you can ask and you're not just writing it down. So once you have it written down, look at it for a second. Does it all make sense? If it does, why don't you guys try -1 and 11, and I'll ask you how to do it in just a second. If it doesn't, ask me a question about this. Okay, who wants to do the next one? Abigail, go.
A times negative 1 cubed plus B times negative 1 squared plus C times negative 1 plus D equals 11.
Beautiful.
Ah,
All right. 2, 5. Who wants to do this one? Maya.
yes.
Go, Maya.
A times 2 cubed plus B times 2 squared plus C times 2 plus D equals 5.
Last one. Anybody want to try it? Anybody besides Abby and Maya?
Abigail.
Okay, go, Shane.
A parentheses 3 squared cubed plus B parentheses 3 squared plus C parentheses 3 plus D equals 27.
Okay. Once we have that, right, we make our matrices. Okay. I'm going to do the first one. Negative 2 3 times is negative 8. An interesting fact, if it's to an odd power, it's going to be negative. If you have a negative to an odd power, it's going to be negative.
Right.
And if you have a negative to an even power, it's going to be positive. So negative 2 squared gives me 4. Negative 2, 1, and I'm timesing this to the I'm raising it to the negative 1, times the answer matrices, which is 17, goes in the top. Who wants to do the second one? Go ahead, Lindsay.
Negative 1
Mm-hmm.
1
Wait. Negative 1, 1. What comes next?
Oh, no. Negative
Then,
Oh.
and in the answer matrices? Yeah, that's great. Okay, next one. Anybody want to try? Go ahead, Shane. 2 times 2 times 2. Okay. Then, and the answer matrices? Okay.
Oh, yeah.
I thought you said that,
Jeff, you want to do it? Okay.
I said
Hold on, somebody has a question. 1 second. Yes.
I thought you said it was like 2.
negative 2
So it's not a negative 2, right? It's a positive 2, Allison? Did that answer your question? Okay, Jeff, go.
7,
Awesome.
9,
Yep.
3,
Mm-hmm.
1,
Good.
and then 27.
Good. Okay, let's put that in our graphing calculator, please. Okay, I'm going to pull up Live Presenter again so you can see, because I have a lot of people getting this incorrect. If you are not entering this into your calculator, you're doing yourself a disservice. We have a test next Friday. This stuff will be on it. You will not have a chance to practice this at home, right? Because you don't have it at home. Okay. So the first thing I'm going to do is open up matrices. I want a 4 by 4. So I'm going to delete, hit 4, tab, delete, hit 4, press OK. Plugging in negative 8. I like the tab button. 4, negative 2, 1, negative 1, 1, negative 1, 1, 8, 4, 2, and 1, 27, 9, 3, 1. And I'm going to raise it to the negative 1 times that by
17
matrices. Make sure it's row 4, column 1. Good, Abigail. And I'm gonna have, go ahead, Olga. Yep,
11,
yep,
5,
yep.
27.
Did you get your answer? 1, 2, -7, and 3.
Of course.
Okay, I'm gonna go back to my paper and write out what this means. And I'm gonna give you one more problem after this to do in class. Okay, so my answer for this was 1, 2, -7, and 3. That means 1x cubed plus 2x squared minus 7x plus 3 equals y, right? That's my equation. Okay, last one, we're going to do a quatric.
Wait, give me a minute. Okay, thank you.
Okay, calculate a quatric. Spell it this word differently every time. So how many points do you think it has to have?
5.
Okay, my points are -2, -50, -1, -19, 1 and 1, 3 and 125, and 4 and 376.
Oh my goodness.
Remember, big numbers shouldn't matter. They shouldn't matter. Okay? What does this look like? Ax to the what? 4th. Plus bx plus cx plus dx plus c equals y. Oh, e. That's an e. I don't know why I put c. Okay, Abigail, don't freak out. You're doing really great.
I understand it, just getting too long now.
Okay.
It's not even fun anymore.
All right. We're plugging in -2 and -50, okay? So I'm going to do the first one. A times -2 to the 4th plus b times -2 to the 3rd plus c times -2 squared plus d times -2 plus e equals -50. Who wants to do the next one? They got lots of negatives. Okay, go.
Hold up, let me write it out. Alright, okay, so A
Mm-hmm.
times -1 to the 4th plus B times -1 to the 3rd plus C times -1 to the 2nd plus C times -1
Plus
plus
e equals.
-19.
Okay. Next one. 1, 1. Should I just do them?
Yeah.
Okay. A times 1 to the 4th plus b times 1 cubed plus c times 1 squared plus d times 1 plus e equals 1. I know I'm going fast, but are we okay with it?
Yeah.
Can't read that fast.
Oh.
All right. Ready for the next one? 3 and 125. I will totally wait. You ready? Okay. A times 3 to the 4th plus b times 3 cubed plus c times 3 squared plus d times 3 plus e equals 125. Last one. 4 376. So a times 4 to the 4th plus b times 4 to the 3rd plus c times 4 squared plus d times 4 plus e equals 376. Good? Okay. Next part is we make a... Okay. Alright. I'm going to do the first one. Negative 2 times negative 2 times negative 2 times negative 2 is positive 16. Negative 2 cubed is negative 8. Negative 2 squared is 4. Then we get negative 2, 1. We raise this to the negative 1 power. Times my answer matrices, which we get negative 50. Okay. Anybody want to try the next one? It's probably easy. So what? The first what? Negative 1 to the 4th power is 1. Then negative 1 to the 3rd power would be? Then negative 1 to the 2nd power would be? And then 1, 1, negative 19. The next one should be really easy, right? Because it's just all ones. 1, 1, 1, 1, 1. And the answer is 1. Next one. 3 to the 4th power is 81. 3 to the 3rd power is 27. 3 squared is 9. 3 to 1 power is 3. E is always a 1. We get 125. So far, so good? 4 to the 4th power is 256. 4 cubed is 64. 4 squared is 16. 4 to the 1st power is 4, and 1 is just 1. With the answer is 376. What are we going to do next, guys? Put it in the calculator. Okay, I'm going to change this to live presenter so you can see what I'm plugging in. Okay, so this is a 1, 2, 3, 4, 5 by 5 matrices.
I deleted it.
Okay. So I'm going to put in, I'm not going to say this out loud because I don't want to mess you guys up. But please, if you get a different answer than me, know that you can look up here and check your answers to see what you might have accidentally put in incorrectly. Don't forget to times it by your answer matrices. Again, I really strongly suggest that you practice this and don't just go ahead and wait for me to give you an answer. You do not have a calculator at home, but you will be expected to be able to do this on tests. Okay, this should be your answer. Oh, no, I plugged in something in wrong. That is not right. Okay, let's see what I did wrong. Ah, that's important. Okay, so my first row, this is supposed to be -2. Nope, it's supposed to be -1.
-16.
1, 1. I'm not supposed to have a -16.
It's 1, -1, 1, 1, 1. you put a negative 1 under the negative 2, and it's supposed to just be all ones.
No,
I don't
that's the
think
next
it's
one.
well.
No, that one's right. One underneath it's supposed to be all ones.
That one is all ones.
Okay, let me see.
There's two.
There we go. That's the right answer.
What do you mean? That's what I got.
So, 1 to the 4, negative 1 to the 4th power is 1.
Okay.
Negative 1 to the 3rd power is negative 1. Negative 1 squared is 1. Negative 1, we always have a 1. So, you should get 1, 3, negative 6, 7, and negative 4. If you didn't get that, there was a mistake. Double check your answer here. Okay? I'm going to real quick move away from this to put up my paper so we can put our final thing down, which is to put in what this means, what my answer means. So I know that this equals 1, 3, negative 6, 7, 4, which means 1x to the 4th plus 3x cubed minus 6x squared plus 7x plus 4 equals y. Okay. Your homework for tonight. Your homework for tonight is writing matrices from points homework. Okay? You're going to write the coefficient and constraint matrices for a cubic polynomial like this. You're going to write these. That passes through these points. So you need to go through this process twice. It tells you right here to remember what these equations look like. Okay? So one like the cubic, one like the quadratic. I need to see the final. You could you could turn it over on the back and work on it, and then make the matrices on the front if you want. But I need to see this is the coefficient matrices to the negative 1. This is the constraint matrices or the answer matrices. Yes. You're right. It says it on my paper. That was a negative 4. On my calculator, it says negative 4. Thank you. Okay. Now I'm going to stop recording. Everybody knows what their homework is. They have examples. Should be good.
Fantastic.
I'm glad you feel that way, Abigail.